So this is the RCA ACR-111 again, and if anybody's watched the previous videos and read the posts, I'll see that I suspect that the local oscillator signal is sort of blocking the front end of this radio somehow, and it's either a poor bypass or something like that. So I investigated a bit more, and I found that some of it is leaking through the HT line, not a lot, a very small amount. But quite a bit is leaking through the AGC feeds to this first and second RF stages. So I've added a little bit of extra bypass, just 1000 picofarad disc ceramic onto sort of a node right in the heart of the coil pack there on the AGC line. So 1000 picofarad will not alter the AGC time constant hardly at all, but it made quite a bit of difference on the amplitude of the signal. And on the scope there, the purple signal is the local oscillator, just a reference. It's just loosely coupled to the local oscillator, and the yellow is the signal on the second RF stage grid. And that's the local oscillator signal. You can see that about 16.4 megahertz, and it's still quite a sizable signal. It's still half a volt thereabouts, and you can hear the tone of a signal generator in the background. That's a signal generator feeding in at 16.8 megahertz roughly. Now watch what happens if I put an extra 1000 picofarad disc ceramic at the other end of a wire in this RF stage here, still on the AGC line. Watch what happens to the strength of the local oscillator signal. That's the yellow trace on the second RF grid when I do this. It halved the signal, roughly half the amplitude of the local oscillator signal that's been seen on the second RF stage grid, but also the gain of the RF stages increased quite a bit, significantly. I would say probably by about 5 times. Maybe more, maybe about 8 times according to the output meter. The problem is if I connect this up and then I tune the radio to a different frequency, the response changes. So what's happening, I think, in the RF stages here is it's a poorly designed RF stage with these long leads, greater coils at the opposite end of the coil pack, and there's it all bunched around the bandy coil, which is a short fat coil at the front there. And I believe that it's just a poorly designed stage here, and there's all sorts of resonances happening at different frequencies, and no amount of adding additional bypass capacitors, even at different values, really cures that right across the frequency range of band E. So you can get it working well on one part of the band by adding the bypass caps of certain value at certain points in the circuit. You tune it to another part of the band, a few megahertz away, and you've got a worse problem. So I'm not really sure if I can resolve this issue. I think it's an inherent design flaw, probably exacerbated by age. And it's just such a shame because the response is way down where it should be. I think I've got it better than the 16 decibels down where it used to be, but it's not as good as the band D response, for example, on 12 or 15 megahertz. So I'll get it as best I can, and then I'm going to box it up, retune the RF stages, and then call it a day for this receiver. I've been on it since July, and it's now mid-October. So I think I've exhausted all my energy on this. I've left it for a week or so and gone back to it and gone back to it again, and I think I've got the problem nailed. It's just that the resolution of it is inherent in the design, and it cannot be resolved. And unless I see another identical receiver that's working perfectly on band E, and check out the coil packs in that one as well, I won't be convinced it's anything other than a combination of poor design. Maybe the old caps had a different kind of characteristic to the yellow caps I've used here. Maybe all that sort of builds into it. It shouldn't. We're only talking up to 30 megahertz here, but there is definitely an issue with resonances in this RF stage, and the amount of leakage from the local oscillator, the sort of gobs of RF getting through into the first two RF stages, even with the screening boxes on. So anyway, it's better than it was, not perfect. I'll measure the improvement later, but I just thought I'd give an update as to where things were at. And once again, I'll just add that 1000 picofarad capacitor to the AGC line on the second RF stage. Pretty consistent, eh? And if I change the frequency, you can see the amplitude varying there. Now if I put the capacitor back on again, no difference at that frequency. So we're now talking at about 11.3 megahertz, and adding that capacitor hardly has any change in the amplitude. In fact, it increases it slightly. So that's what I mean. The resonances are all over the map, and it's really just poor design. Or the capacitors that they used originally were somehow special, and they did the business. But I really can't see how a 1930s capacitor could be better than a 2020 capacitor. So anyway, there we go. RCA ACR-111 with a persistent problem in the RF stages.